Hello. Okay, cool. Finally, things are working a bit fine. Um, I'm not sure how things keep on changing on my um
Hello. Okay.
computer.
Cool. Finally, things are working a bit fine.
Alrighty. Cool. Yeah, hopefully you guys are doing well. I had a couple of small issues with the OBS and YouTube because the streaming environment for OBS versus Twitch is way different. Things work a bit more differently, and that's why sometimes there's a lag. And I wasn't seeing my own photo or like the video, the live footage. I was not able to see on the browser, so I thought I was not online. That's why it kind of took some time. And I'm just waiting, like, let's say a couple of seconds. And if you have any questions, feel free to ask. Um, I'm just waiting for a couple of seconds so people join, and I'm just settled down, making sure all the audio, video, and all those stuff are good. So, so let's get this stuff going so I can start. This is Terraform is like one thing I've heard a lot in the DevOps industry. A lot of people talk about this and use it, rather, I will say. So this is something. So this is something like a lot of people use in the industry. They talk about this. They have this idea that like clicks, the human nature is like if you're going through clicks, like usually is like when you want to start a server, you go through many clicks through the portal of Google Cloud or any other cloud provider, and that can create issues, can lead to inconsistency and stuff like that. So with this Terraform, you don't have to. With Terraform, everything is like written as a code, right? Like a JSON. So, and that is like you just change it at one place. Everything else will use that same template for infrastructure. And then everything else will change. Or for future, you can have those specific template. And that's the best part about like how the coding in cloud is done, because these type of advantages you won't see in like in on-prem type of development environment, because they don't have this thing. There is legit no like Terraform itself is a, you have to install those things, you have to comply by those things and stuff like that. So that's a beautiful nature of cloud, and this is like again why cloud is so used. Cloud has so many advantages. This is one of those reasons. And so without further ado, here I'll just start going, and let me just share like my screen. My screen will look kind of different as I was working on something from last couple of days. I have been like going into a bit more on the gaming. Not going into it. I was already there. I never used to stream it, so somebody told me just stream it, and so yeah, that's what I have been doing. Kind of. Hopefully, you guys like that as well in future. But yeah, so without further ado, here I'll share my GCP related fit to screen. Where is the transform? So yeah, I can just start sharing my screen. I hope I don't accidentally share anything that I should not. And with that being said, um, let me just share it and get going. Where is my transition? Boom. An interesting part about this, you cannot see my face right now, like other than through the. Now it should come. Okay, never mind. Webcam. Okay. Just kind of trying to make it work type thing right now. This is kind of hard, way harder than I thought, honestly. These things have a lot of stuff built on top of each other. So yeah, but as you can see now we are here. I'll just share this path with you guys in this message. This is the exact course we are working on right now, and let's get going here. I hope I made the transition right. Now you will see the transition. And yeah, cool. As you can see now, my whole thing, and I've shared the path with you already. I don't need these much stuff. But yeah, so let's get going. We are working towards getting started with Terraform for Google Cloud. I've got some of my OJ here with me. OJ, what people don't know, orange juice. I love drinking orange juice because it actually like is good for like cholesterol and stuff. I've heard it reduces the cholesterol and so the heart diseases. And I got my boy Loki here. So let's get going. Again, if you have any questions, I a lot of time I am not like 100% looking at the chat because I'm just too much involved in the course. But if you have any questions, feel free to like point out regarding what you have any questions, and I will try to answer to the best of my knowledge. So for this, we are working towards our cloud engineering learning path, getting started with Terraform for Google Cloud. Here, it's a 8 hours one, introductory with 16 credits needed. I have like around 500. So this course provides, I'll just increase the. This course provides an introduction to using Terraform for Google Cloud. It enables learners to describe how Terraform can be used to implement infrastructure as a code. This course provides an introduction to and how to apply some of its key features and functionality to create and manage Google Cloud infrastructure. Learners will get hands on practice building and managing Google Cloud resources using Terraform. When you complete this course, you can earn the badge displayed on the right. View all the badges you have earned by visiting your profile. You will see a bunch of badges are associated with my profile. I've been like working on Google Cloud for some time now, just practicing things, learning. So yeah, enroll. Let's start the course. Course discussion. Oh, this is new. Error while creating cloud. So interestingly, we don't care about the course discussion for now because majority of the code, like you can see with the discussions, like they are like asking for vouchers and stuff and things like that. So Not needed for our course, I will say. So I'll just toggle it back. Now let's get going. Course introduction. This is a video. Doesn't appear to be here. Huh. Where is the video? Course overview is here. Course introduction, 2 minutes. YouTube.ca. Oh, this video is not available anymore, I believe. Oh, interesting. Console. Wait. Oh, that's interesting. This video itself, like I think YouTube don't have it available right now. Um, this is my way majority of the time, youtube.com. Interesting, interesting. So let's go to YouTube and search for this. Oh, this account is not yet eligible to use YouTube. Okay, so what we can do is that's interesting. um, so what I can do if this I'm getting this account issue, which I shouldn't have in the first place. Sign in, yeah. Come on. Okay, this is now available. So that's good. Finally, this is interesting that even for Google, um, this thing we need that. So let's get going. Increase the resolution to 180p.
What is Terraform and how can it be used to help you manage your infrastructure?
And what is infrastructure as code and how can it benefit the business?
If you're asking yourself any of these questions, you're in the right place. Terraform is an open source infrastructure as code tool by HashiCorp for provisioning resources, including Google Cloud resources with declarative configuration files. These files can be shared amongst team members, treated as code, edited, reviewed, and even versioned. This enables you to build and deploy complex Google Cloud infrastructure by running a few simple commands.
So basically, it is like a cloud, and it is like a code, right? You can share, edit, um, create it, edit it, review it, and then version it. So and even test it. So
In the Getting Started with Terraform for Google Cloud course, learn how to use Terraform, an infrastructure as code tool, to create and manage your Google Cloud infrastructure.
Hello, my name is Rekha.
And I'm Owen, and we're both course developers at Google Cloud. We want to welcome you to the Getting Started with Terraform for Google Cloud course.
The purpose of this course is to explore the Terraform workflow in detail.
You'll become familiar enough with the Terraform workflow that you'll know the purpose of each phase and how it's implemented.
This content is designed for DevOps engineers, cloud architects, cloud engineers, and anyone who's interested in using Terraform to create and manage their Google Cloud infrastructure. This is a fundamental course that covers the basics of Terraform for Google Cloud.
The prerequisite for this course is Google Cloud Fundamentals Core Infrastructure. You'll also need to have basic programming skills, a familiarity with using CLI, and a general familiarity with Google Cloud.
So with this, for core infrastructure, you can look at my previous online live streaming and basic programming. I assume you guys have that. CLI and Google Cloud, we will do it because I have installed WSL, which is basically Linux on Windows. And we'll use those. We'll use that for our cool cloud and stuff.
Using CLI and a general familiarity with Google Cloud. Through a series of videos and hands-on labs, you will explore the business need for Terraform and infrastructure as code, and the benefits of using it in your environment.
You'll learn about Terraform's features and functionalities.
You'll also Through a series of videos and hands-on labs, you will explore the business need for Terraform and infrastructure as code, and the benefits of using it in your environment.
You'll learn about Terraform's features and functionalities.
You'll also be equipped to use Terraform resource blocks, variables, and output values to create Google Cloud infrastructure resources, and the benefits of using it in your environment.
You'll learn about Terraform's features and functionalities.
You'll also be equipped to use Terraform resource blocks, variables, and output values to create Google Cloud infrastructure resources.
You'll also learn to use modules to build reusable code.
In addition, you'll be equipped to explain the Terraform state file and its importance. Are you ready? Well, let's get started.
Yeah, what I was saying is last one will be interesting to learn about Terraform state file. I never heard what Terraform state file is, and this is something interesting to learn. TF state.
Yeah, what I was saying is last one will be interesting.
Terraform logs information about the resource it has created in a state file. This enables Terraform to know which resources are under its control and when to update and destroy them. Okay, by default it's named Terraform. Hmm. Okay, this is a configuration, Terraform, write state, read state. This is interesting. Alrighty. Let's get going in the next introduction.
Hello, and welcome.
What's this one? Introduction to Terraform for Google Cloud, terms and concepts, writing infrastructure code, organizing, reusing, configuring Terraform modules. Okay, let's get going.
Hello, and welcome to the Introduction to Terraform for Google Cloud module.
Are you able to hear this? At least, hopefully, right? If not, let me just.
Hello, and welcome to the Introduction to Terraform for Google
I see you guys are not able to hear it.
Are you able to it?
One sec.
Cloud computing has played a major role in how companies build, scale, and maintain technology products. It has
Okay.
transformed how products and services are provisioned.
My apologies, you guys can hear it actually.
This is hopefully right.
Okay. See.
Hello, and welcome to the Introduction to Terraform for Google Cloud module. Cloud computing has played a major role in how companies build, scale, and maintain technology products. It has transformed how products and services are provisioned. The ability to provision cloud infrastructure in just a few clicks has proven to be simple and highly productive. So why would you want to use lines of code to provision your infrastructure? What is infrastructure as code, and what are its benefits in using? And what's the difference between infrastructure as code and Terraform, and how do they relate? In this module, you'll find the answers to these questions. Starting with the basics, this module provides an overview of infrastructure as code, or IAC, which is the basic concept for Terraform. You'll also learn about the features and benefits of using Terraform, as well as exploring how it can be used as an IAC tool for Google Cloud. You'll then investigate how Terraform transforms lines of code into infrastructure. This module concludes with a short quiz and a recap of the topics covered. Let's jump in.
After that.
Let's start with the fundamental concept required to understand Terraform, Infrastructure as Code, or IAC. With IAC, you can write code using a configuration language to define, provision, and manage your infrastructure. Gone are the days where a system administrator had to manually configure hundreds of servers, networks, and firewall rules by interacting with a user interface. With IAC, you only declare the desired end state of the infrastructure. IAC handles the managing and provisioning. The rapid increase of business demand has manifested a cultural shift known as DevOps. DevOps emphasizes collaboration and communication between developer and operation teams, and automates software delivery and infrastructure changes. Let's explore some challenges and the role that IAC plays in addressing them. With competition growing among industries to benefit from the cloud, DevOps teams are struggling to manage growing environments and rapidly expanding businesses. This struggle involves four major challenges. First, high business demand requires rapid scaling of IT infrastructure across industries. Due to the rapid scaling of IT infrastructure, ops teams must overcome new operational and technical bottlenecks, such as managing infrastructure consistently at scale. When infrastructure is changed, DevOps teams often struggle to collaborate with and audit changes. Closing the communication gap is imperative for successful deployments. Increased quantity and scale has also led to human or manual error that can potentially have significant effects. Now, let's discuss the benefits of IAC. First, it's declarative. Instead of having to specify the exact sequence of steps to make a particular change, you can focus on the desired state of the infrastructure. For example, you might want to use a production label to specify 3 subnets across 2 regions. Terraform will update the live state to match the desired state by adding a label to the existing subnet and creating 2 new subnets in additional regions. And
Let's go back.
specify 3 subnets. For example, you might want to use a production label to specify 3 subnets across 2 regions. Terraform will update the live state to match the desired state by adding a label to the existing subnet and creating 2 new subnets in additional regions. Through declarative abstractions, IAC tools manage the implementation details so that you can focus on the changes made to your desired state. This declarative approach allows anybody to read the state of an infrastructure as opposed to asking the system administrator. Another benefit of IAC is that it's managed in the same way as application source code. Typically, if you make changes directly in the Google Cloud console that cause an outage, you'll have to manually identify the breaking changes, an error-prone process. With IAC, you can see a full history of versions and infrastructure changes. If something breaks, you can roll back to a previous state. The entire history of your infrastructure is captured in the commit log. Version control also enables developers to collaborate on changes. For example, perhaps a developer needs a port opened on a firewall to support their application. They can simply submit a pull request to the open port instead of waiting in a queue for an administrator to manually open it. Changes can be discussed, reviewed, and audited without creating information silos, which can lead to more collaborative ownership as infrastructure evolves.
What it means by silos is, when you are, let's say, have server only couple of people in this, or just a small team, people in the same small team will know, okay, this port was open in the firewall, other won't have any clue, and they might think, oh, they got hacked, or they had zero knowledge, or they never paid attention. And let's say now this team don't need that port, other team don't know that they don't need this port, and because of this communication gap and like being in the silo or a, how to say, disconnected region, not so much talking to each other, that can create issues. And so this will solve that issue.
IAC also features an auditable history of your infrastructure. Typically, infrastructure doesn't contain comments. You might see changes in audit logs, but it's often difficult to understand why those changes were made. With IAC, you can include explanations. For example, you might comment that a specific subnet allocation is required for a certain application. This auditable history gives a clear view of how infrastructure has evolved over time. When proposing new changes, you can also preview them and inspect how they will affect the live infrastructure before they're applied. These previews let you detect drift and ensure that your infrastructure remains robust.
Let's go back to this one.
For a certain application. This comment that a specific subnet allocation is required for a certain application. This auditable history gives a clear view of how infrastructure has evolved over time. When proposing new changes, you can also preview them and inspect how they will affect the live infrastructure before they're applied.
So, interesting thing about this regarding auditable need for being auditable, um, not a lot of people know is that auditing is used and are set according to certain standards. For example, it will be ISO, International Organization of Standards, even though it's called ISO, the International Organization of Standards. It should be iOS type thing, right? But we already have iOS. But yeah, so that was ISO was created in the ISO 27001. Certificate is for like cloud and these tech companies to have, and there are like other uh, GDRP, if I'm not wrong, HIPAA and all those auditable one to make sure things are, the infrastructure has like certain level of security posture in their infrastructure. So that's what it is about. Like it helps in that auditing. So when an external auditor, because to get that certificate, it's always a third party auditor you need to get to approve your certificate, give you that certificate. So they will look at this IAC and then you can justify, okay, why this port is open, why these ports are closed. And once you are able to justify, that means that you know what you are doing. You just don't have the ports open for no reason. There's a reason for this port to be open and this is closed and this type of service being provided. So those are important. This is how for DevOps part, this is help in that auditable certificate.
These previews let you detect drift and ensure that your infrastructure remains robust. Portability is another benefit of IAC. You can build reusable modules that encapsulate conventions and let you consistently build infrastructure from a shared template. Instead of having to rebuild infrastructure manually, you can have many instances of the same template deployed for different applications or regions. Google Cloud has developed reusable modules that can be found in the Cloud Foundation Toolkit. Using the library of reusable, documented, and tested infrastructure code makes it easier to scale and evolve your infrastructure. Provisioning and configuring are two terms that are sometimes misinterpreted.
Before going into this, let's look at Google Cloud Foundation Cloud Foundation Toolkit. Okay, so basically you treat your infrastructure like software, blah blah blah. Our customers. So they have like certain stuff already in place. Okay, let's see why this is recommended and this is not. Resource Google Compute Instance, web server, name equal web server, all configuration objects using underscores To eliminate. Okay, this one has underscore and this one. Okay. So certain which are configurable, I'll be using underscore, stuff like that. Uh-huh. Interesting. So these are like kind of the grammatical stuff they're talking about. Like whatever, like you know what grammar is for people, right? Like for English, this is like those grammatical type things, right?
Nested infrastructure code makes it easier to scale and evolve your infrastructure. Provisioning and configuring are two terms that are sometimes misinterpreted. Fundamentally, IAC is used for provisioning and managing cloud resources, and configuration management is used for VM OS level configuration. For example, infrastructure as code configured to scale and evolve your infrastructure. Provisioning and configuring are two terms that are sometimes misinterpreted. Fundamentally, IAC is used for provisioning and managing cloud resources, and configuration management is used for VM OS level configuration.
Oh,
For example, infrastructure as code creates and provisions a VM instance, and the configuration management configures the internals of the VMs.
so provisioning, I will say, like type of thingy, like starting or giving birth, or in those lines, like I provision instead, I created instance, I gave birth to it. But like no, create, that's a better word. Configuration is like whatever is created, configuring the characteristics or features of that thing.
Configuration management is a broad topic that covers more than we'll discuss in this section. To simplify, activities like configuring a VM for application dependencies are considered configuration management. Configuration often consists of manual tasks such as starting services, installing dependencies, installing applications, and running updates. To elaborate, the term infrastructure as code refers to frameworks that manipulate Google Cloud APIs to deploy the infrastructure required to run application code. In contrast, configuration management refers to package configurations and software maintenance. Let's look at a common example to differentiate between provisioning and configuration. IAC automates tasks involved in launching a GKE cluster into Google Cloud, and configuration management automates tasks involved in deploying containers into the GKE cluster.
Task for launching GEKE plus.
Launching a GKE
Okay,
cluster
okay.
and configuration. IAC automates tasks involved in launching a GKE cluster into Google Cloud, and configuration management automates tasks involved in deploying containers into the GKE cluster. An important principle to understand about infrastructure as code is that it's declarative. Most programming languages use an imperative model, where you specify the exact action that you want to take, such as create 5 servers. This model is challenging for infrastructure, because if you run the script again, it may create 5 new servers, even if some exist already. Imperative workflows make it difficult to determine the difference between the live infrastructure and your desired state, leading to repeated resource creation. With IAC, you can declare the desired state of your infrastructure and let the tool determine the details.
I see. So in AWS with auto scaling group, you can have multiple with the launch configuration of let's say the EC2 instance, which is the server instance of virtual machine. You can define, okay, this is the type of virtual machine I want, and you use a separate portal or separate like um how to say pane, all right, or like separate window to like tell, okay, how many servers you need. Sometimes it goes up and down based on your need. But here, let's say it's saying that, hey, inside that launch template, you define how many servers, so you don't have to like worry about how it's going. Let's say if one server goes down, it still will have it will bring up one server, stuff like that.
For example,
So that's good.
you might want to declare that you should have 5 servers. The first time that Terraform runs, it might create all 5 servers. Then, let's say someone accidentally deletes a server. The next time Terraform runs, it would recognize that 4 servers exist and only restore the missing server. We encourage adopting declarative infrastructure tools like Terraform.
Important note: these are like batch type codes, and these are batch type applications, so they will keep on running again and again based on the time you have set. Or you can even create like alerts, just like notification on your phone. Well, how does that happen? Let's say there are 5 servers, somebody deleted, or even for some reason one of the servers went down. The load balancer is always checking, right? If the 5 servers are there, let's say it says, oh, one server went down, that load server will create like a notification to Terraform and say, hey, there are only 4 servers. Terraform will, so that's one way to do it. Second will be, if you are not using load balancer, you're using something else and that cannot create alert, you can say Terraform, hey, make sure I need 5 servers after every 1 hour, keep a check and see if 5 servers are there. If not, if there are more, bring it down to 5. If there are less, bring it up to 5. So different ways to do it. Alert is best way, I will say that.
Focus on how the infrastructure should be, and let the automation handle the details of updating the infrastructure to match your desired state. Declarative management focuses on what rather than the how.
So how and what, those are different ways. Think about stuff.
You now know the basics of IAC, but what exactly is Terraform? Terraform is an open source infrastructure as code tool created by HashiCorp that lets you provision Google Cloud resources with declarative configuration files.
Good part to know it's open source, so you will find a lot of good resources, specifically one from the code camp, really good one on Terraform.
That lets you provision Google Cloud resources with declarative configuration files. Examples of resources include virtual machines, containers, storage, and networks. Terraform allows infrastructure to be expressed as code in a simple, human-readable language called HashiCorp Configuration Language, or HCL. Terraform reads configuration files and provides an execution plan of changes, which can be reviewed, applied, and provisioned. At a high level, Terraform lets operators author files containing resource definitions of the Google Cloud provider and automates the creation of those resources. Terraform features include multi-cloud and multi-API support. Terraform supports all major cloud providers, in addition to Google Cloud and API-exposed services such as GitHub and Kubernetes.
The multi-cloud is one of the reasons why I like Terraform. It makes your company cloud agnostic, and that's what everybody should be going for, in my opinion. Even for example, let's say one of your major provider might be one, but have a second plan just in case, because even for Netflix, AWS is there. Netflix is one of the biggest customer clients of AWS, but they 4 years ago, they have shifted some of their load to GCP, just like becoming cloud agnostic. So remember that.
And Terraform supports all major cloud providers, in addition to Google Cloud and API-exposed services such as GitHub and Kubernetes. An open source structure with 3 different editions that range from self-hosted to fully managed, including enterprise support. A large community, including a registry of publicly available modules for Google Cloud deployments. And infrastructure provisioning rather than configuration. To Google Cloud and API-exposed services such as GitHub and Kubernetes. An open source structure with 3 different editions that range from self-hosted.
Open source with enterprise support, not open core. Maybe.
An open source structure with 3 different editions that range from self-hosted to fully managed, including enterprise support. A large community, including a registry of publicly available modules for Google Cloud deployments. And infrastructure provisioning rather than configuration.
Important one about this is every single cloud provider, just like they have their own clouds, to make it helpful for people and more attractive for developers, they have their own GitHub repos with these template bunch of hundreds of templates at least. I will say some might be even thousands. For example, for Kubernetes to give them examples and make them easy to just copy paste these stuff when they are needed, right? Or like certain blocks, as everything is in modules.
You can use Terraform for Google Cloud to provision resources, meaning that you can use resource blocks to define infrastructure elements such as VMs, networks, and firewalls. You can create explicit dependencies between resources, so that a given resource can only be created after the creation of another resource. You can standardize how a given resource is created by creating reusable modules. And you can limit the values provided for a given resource argument using validation rules.
So provision basically create resources, create resource dependency. You can have like, okay, this virtual machine, you can even define, right? Like this virtual machine should only be created once the database server is online, things are working, right? Standardize, everything will be standard. Validate inputs to resource arguments. Okay, so you can like validate input. So make sure, okay, once you have created what the output is, okay, if it is created in this region and stuff, if I'm not wrong, you can limit the value provided for a given resource argument. Okay, so you can just define, okay, these are the only ones I need. So let's say for virtual machine, if you're a DevOps person, you have created this HCL, HashiCorp language, whatever. So yeah, in that you have defined the virtual machine. You can define, okay, I need certain arguments from the developer whenever they're creating a new or provisioning a new instance, like, okay, what region, how much CPU, how much RAM, stuff like that. With just those couple of arguments, you can just say, okay, which region or which subnet. That's all you get, like you can define and then give them that.
For a given resource argument using validation rules. Next, let's view the standard IAC configuration workflow. Before jumping into the Terraform workflow, you must determine what resources should be created for a project. For example, for a common two-tier architecture, you will need a pool of web servers that use a database tier. Therefore, during the scope phase, you should scope requirements for the Google Cloud resources and plan how they should be connected. In this case, scope the type of compute and database instances needed. The Terraform workflow begins with the author phase, where you author the configuration code for the infrastructure you want to create. Referring to our example, during this phase, you code the configuration of the instances and the VPC network. Then, you organize your code into configuration files, such as variables, main, and tf-vars.
Terraform variables.
The next phase is initialize, where any plugins or modules are installed. During this phase, you run the Terraform init command, which initializes the Terraform configuration directory and installs Google Cloud as the provider. In the plan phase, you run the Terraform plan command. The Terraform plan command provides an execution plan for the resources created, changed, or destroyed as per the configuration defined in the author phase. You can then review the plan before applying it to your Google Cloud infrastructure. After you review the configuration described in the generated plan, apply it to create the infrastructure and a state file. Later in the course, you'll explore the Terraform workflow in more detail. Now, let's examine common Terraform use cases. Terraform is used to manage infrastructure. It takes an immutable approach, meaning that you write code to reduce the complexity involved in upgrading or modifying the services and infrastructure. Terraform is also used to track infrastructure changes. Whenever a new change is planned or applied, you will be prompted to approve the change before Terraform modifies the state of the infrastructure. When an infrastructure is created using Terraform, a state file is automatically generated. State files reflect the current state of your infrastructure and provide the amount and type of Google Cloud resources modified in your configuration. Terraform is used to automate changes. Because configuration files are declarative in nature, you do not have to write detailed instructions to build the infrastructure. You only define the end state. Terraform manages the dependencies and provisions the resources. It's also used to standardize configurations. You can use modules to save time and implement best practices. You can also leverage publicly available modules in the Terraform registry. Terraform can also be used to automate the enforcement of policies on the types.
So automate changes. So the last one, standardize the configuration modules with best practices and stuff. That's like the one I was talking about on GitHub and all these like GitLab stuff, where these cloud providers have already built their repos and accounts, and for Terraform, Kubernetes, stuff like that, they already have bunch. Even like web apps and all those, they have bunch of templates already out there, so you can like majority of the time just copy paste the stuff. But I want to go back here. This is important. Like track changes, we know it's like because it's source code, you can track the changes, pull requests and stuff like that. But I want to go with the third one. That's
Where a
important.
new change is planned or applied, you will be prompted to approve the change before Terraform modifies the state of the infrastructure. When an infrastructure is created using Terraform, a state file is automatically generated. State files reflect the current state of your infrastructure and provide the amount and type of Google Cloud resources modified in your configuration. Terraform is used to automate changes. Because configuration files are declarative in nature, you do not have to write detailed instructions to build the infrastructure. You only define the end state. Terraform manages the dependency. You only define the end state.
So I don't have to define, okay, use I just have to say, okay, create a virtual machine which uses Ubuntu, have 8 GB RAM, of vCPU, and like 32 GB of um, storage, and this much of high input output networking capacity, and it will do. I don't have to define, okay, how to do it, how to install Ubuntu, and all those. So that's
Terraform manages the dependencies and provisions the resources. It's also used to standardize configurations. You can use modules to save time and implement best practices. You can also leverage publicly available modules in the Terraform registry. Terraform can also be used to automate the enforcement of policies on the types of resources teams can provision and use. So, how can you use Terraform to create, update, or destroy infrastructure resources?
hmm.
First, you must write your infrastructure as code in configuration files. Configuration files describe to Terraform the resources you want to provision. Terraform generates an execution plan for the desired state, and then executes the plan to build the described infrastructure. As the configuration changes, Terraform can determine what has changed and create the incremental execution plans that can be applied.
Hmm.
Terraform is available in 3 editions: open source, cloud, and enterprise. Open source is a free version of the software available for download on a local machine or compute resource in the cloud. With this version, many features are available with no license cost. You can provision several different types of resources and codify your infrastructure. Open source grants access to publicly available templates so that you can apply code writing best practices. You can only use the open source version on your local machine, and it does not support concurrent deployments. Terraform open source does not have version control, so you can't track changes or ensure that your commits do not affect the infrastructure setup.
Hmm.
With the open source version, Terraform can only be interacted through the CLI, whereas Terraform Cloud and Enterprise come with a GUI option. Terraform Cloud is useful for collaborative environments. Terraform Cloud has 3 plans: free, team and governance, and business. Unlike Terraform open source, Terraform Cloud Business and Terraform Enterprise support concurrent deployment. With Terraform Cloud, like most other SaaS options, the operational overhead is low. Terraform Enterprise is hosted on-premises or on an infrastructure controlled by you. Due to infrastructure maintenance and its integration with Terraform, Terraform Enterprise has a high operational overhead. Terraform is pre-installed on Cloud Shell.
Okay, hold on. Even though it is pre-installed and all those stuff, one thing I need to know about Terraform is the Terraform current deploy. And I need to understand what this is exactly. How do I create parallel Terraform deployments? Deployments feature explained. Let's see what they have to say. Enterprise concurrent. With enterprise number of concurrent runs, deployments can be added. The level of your cloud edition. Okay. So, setting up. Need to go here, copy this, logging again, boss. Come on, come on. I hate the fact that even it shows my email IDs, which is like not good for me. Yeah, let's go like this. Terraform is infrastructure. Here are some configuration settings. Allow you to control how many resources are created concurrently during the execution of Terraform applied. This setting can be adjusted with the speed up deployments, although it's not across different Terraform configuration. Okay. Terraform concurrent deployment feature like feature with example and no other. Oh boy, this is going to take. Terraform concurrent deployment features allows users to deploy infrastructure resources in parallel, enabling faster provisioning of resources across various cloud providers. Okay, so various cloud providers. We don't need that. Well, I have like a project coming up, so I don't have to worry about multiple clouds for now. Parallel, because we are moving from one cloud to another. Parallel resource provisioning. Terraform can analyze the dependency graph of the infrastructure resources specified in the configuration. It identify resources that can be provisioned concurrently without violating dependency. Terraform determines the optimal execution order based on resources. Resources with no dependency or independent can be deployed simultaneously. Okay. Give an example. I remember somebody mentioned during one of my, this is one of the streams is to um, mod it, mod the chat GPT, make changes. Let's see. Make sure you guys can hear.
I remember somebody mentioned during one of my.
Okay, you guys can hear me. That's good. Alrighty. Infrastructure code that allow users to define and provision infrastructure resources using declarative configuration files. One of the features of Terraform is the ability to manage resources concurrently. Yeah. Allows users to create, update, and destroy in parallel rather than sequentially. This can reduce the time required. So this, I think, will be one needed for a very big infrastructure. Let's say, for example, a big Costco, Walmart, stuff like that, where they have thousands of one. For if you have like 3, 4 servers, that should be fine because it's fast anyway. So main.tf AWS, this is the region, count 5, instance type, tag, web, count index. Okay. Example 5 EC2 instances using AWS instance. Resource will be created. Each tagged, right? Count index. So this is something to look into, right? Like all the extra variables we get. When you run Terraform, apply this configuration and form will analyze the dependency graph. I see. If we do parallelism, flag, pushing up to 10 resources this time. That concurrent deployment can speed up the provision. It is also essential to consider the limitations of infrastructure provider and many dependencies between. So using parallelism, that will be required when trying to do the concurrency feature of this, but I don't think we need that for now. And I'm running out, I have like 7:30 meeting. So let's complete this using Terraform one. We'll do the quiz and let's see what we have to cover next later on.
Terraform Enterprise is hosted on premises or on an infrastructure controlled by you. Due to infrastructure maintenance and its integration with Terraform, Terraform Enterprise has a high operational overhead. Terraform is pre-installed on Cloud Shell, but you can also install it on your local machine. You can install Terraform as a binary package or use popular package managers. To manually install Terraform on a Windows machine, first download the package that meets your system requirements. Extract the package. Terraform is pre-installed on Cloud Shell, but you can also install it on your local machine. You can install Terraform as a binary package or use popular package managers. To manually install Terraform on a Windows machine, first download the package that meets your system requirements. Extract the package. Terraform includes a single binary called Terraform. Extract the package to the CLI. Unlike Terraform,
I think this is what we can do with the WSL because I have like 20 minutes, so we can
Terraform Cloud Business and Terraform Enterprise support concurrent deployment. With Terraform Cloud, like most other SaaS options, the operational overhead is low. Terraform Enterprise is hosted on premises or on an infrastructure controlled by you. Due to infrastructure maintenance and its integration with Terraform, Terraform Enterprise has a high operational overhead. Terraform is pre-installed on Cloud Shell.
Terraform Enterprise is more like an on-prem solution. I believe, yeah, that's why its operational overhead is high. Cloud, like SaaS, has less.
But you can also install it on your local. Terraform is pre-installed on Cloud Shell, but you can also install it on your local machine. You can install Terraform as a binary package or use popular package managers. To manually install Terraform on a Windows machine, first download the package that meets your system requirements. Extract the package. Terraform includes a single binary called Terraform. Edit the path variable to include Terraform. and then verify the installation by entering terraform-help into a new terminal.
Show me Linux.
The authentication mechanism.
Never mind. I'm going to do first. I'm going to do is like install on WSL, then we'll move to the next one. So let's go quickly on how to install Terraform on WSL. Um, for WSL version, I will be using, or the flavor of Linux distro I will be using is Ubuntu, of course. Easiest one to download and always available. We'll do a Windows one too, because PowerShell is becoming very, very popular, and I've heard really good things about it, and it's open source in a lot of ways. So yeah, let's do this. Install Terraform on WSL. Let's go. Computing Terraform, Linux subsystem. But have Windows 10 machine. Follow the steps. Install VS Code. Install WSL Windows 10 machine. Towards Ubuntu, however, several distros. Oh, the main one was always just no. This is not increasing it the way I want. Nope. Mind. I wanted it to like increase the font. I know you guys can't see it. One sec. WSL run as administrator. Okay, let's do that. Yeah. You know what? I'm going to increase this a bit here. So hopefully you guys can see this one. I'll take it away here. So let's do our Control V. I have so many passwords I kind of forget. Come on, work. Come on, come on. Okay, finally. I have no idea what the hell is happening. Okay. Where's my WSL? So what I did, I'll do this one quick thing for you guys. I'll do a clear, put it here. So what I did was, instead of 200, let me reduce to sudo app get and sudo app update, right? Upgrade sudo app sudo app update app get update. It's working, getting things done. Now upgrade. There's anything less? Yes. Install it, boy. Installing all the Ubuntu ones. Install Visual Studio Code. I don't want it to install on Visual Studio Code. Um, So our upgrade is done, as you can see. What I'll do, go back to default. We'll check on the, let's see this one, or oh, we could have directly gone to install Terraform. Going to, we have to make sure all these are here. Okay, let's quickly look. You guys can see. I want to make sure when this zoom level, back, let's see, this is even bigger. So if I go here, makes sense what was the issue. Zoom level 25. Yep, I think that will be good. So you guys can see this right now. We are installing GNU PG software properties com. So copied this and WSL. This is upgraded. Now what I have to do is quickly here install HashiCorp GPG key. Okay, GPG key is like a security way to make sure the installation, when you are installing something, it did not get corrupted by like a man-in-the-middle attack or something like that. So looks like it worked. Yep, it worked, I guess. Verify. It did reported as the key print, so that's good. Add the official repository to your system. LSV command find the distribution release for now current. Okay, download the package. Okay, let's install that. Okay, it's signed up and everything. Cool. I need to. Cool. Now we'll do sudo apt install Terraform. So we have Terraform up. Verify with Terraform-help. I will go with Terraform-v just to see. Okay, we have the version 1.7.3 now. So really good stuff, right? And we should I might try to get like a virtual machine, virtual box on my system, so I can show you directly the Linux stuff and things like that. But yeah, I'll just post this here for you guys to have a look. Terraform installing, all those steps are here. So we can just close this really quick, and let's just complete this video.
Help into a new terminal. The authentication mechanism used for Google Cloud varies based on where Terraform is run. The Google Cloud provider, not Terraform, will require authentication to communicate with the resource API for resource creation. Terraform on Cloud Shell is pre-authenticated. Cloud Shell is a compute engine virtual machine, and the service credentials are automatic, so there's no need to set up a service account key. If you're running Terraform on your workstation, authenticate by using the Cloud SDK. You first must install the gcloud CLI, and then run the gcloud auth application-default login command to authenticate with Google Cloud.
Another one, I guess you have to install if you want to use WSL for a Google Cloud series is Gcloud. I'll do that video as well. It's not hard. I've done it in previous version of Windows. This one don't have that, so I'll do that.
If you're running Terraform on a VM on Google Cloud, configure that VM to use a Google Service account. A Google Service account allows Terraform to authenticate without a separate credential or authentication file. Ensure that the VM has the Google Cloud API enabled.
Important. So Google Service account. Google Service account is like, as you are developers, there are developers and other team members in your team. You have identity and access management for all of them through their email most of the time, and authentication account, right? Or IAM account again, right? Giving a IAM account to a service like a virtual machine, that's called a service account. You will see this used all the time, especially in if you're using Intra ID or basically Azure Active Directory AAD, which is now Intra ID. That service account is everywhere in that.
If you're running Terraform outside Google Cloud, you can use a Google Cloud Service account with Terraform. From the Service Account page in the Cloud Console, choose an existing account or create a new one. Then, download the JSON key file, name it something that you can remember, and store it somewhere secure on your machine. Supply the key to Terraform using the environment variable Google_application_credentials, setting the value to the location of the file. Terraform can then use this key for authentication. This method does have a few keys using the environment variable Google_application_credentials, setting the value to the location of the file. Terraform can then use this key for authentication. This method does have a few limitations. Service account keys are short-lived. Key rotation is not allowed, and the keys must be protected. Workload identity and workload identity federation are tools for mitigating short-lived identity tokens when running Terraform outside of Google Cloud. Once you've downloaded Terraform and authenticated successfully, you are ready to start authoring a Terraform configuration.
The CC is not working for good.
Once you've downloaded Terraform and authenticated successfully, you are ready to start authoring a Terraform configuration. Let's create a simple VPC network. We won't get into the details of the code just yet. For now, let's focus on the workflow. First, create a configuration file with a .tf extension. Then, define Google Cloud as the provider and run the terraform init command to initialize the provider. Add the HCL code to create a Google Compute instance. After you save the code, navigate to the directory where you save the file and run the terraform plan and terraform apply commands. After you run terraform apply, a new VPC network named My Network will be created on Google Cloud.
Not going to lie, I'm super tempted to just move my whole, destroy my whole website and just move and try this on the website. So yeah, that's fine. For now, let's do our quiz. As you know, when I was on Twitch, I used to say whatever you have, like I'm going to monitor the chat in this case now. And I'll just pop this out here. Now, if you need, the chat doesn't work like that. So I'll just do it this way. Now for the chat, right, you guys can type the answer here. Whatever you type, I will keep looking at and let me know if I'm doing wrong. Sometimes, majority of the times I'm wrong, but that's how I learn. So if you also have questions, you are thinking about it, let me know. We are here. I'm here. LO. Explain the feature and benefits of using Terraform. Which one of the following statements is true regarding Terraform? Terraform can only be used for on-premise deployments. Terraform Enterprise is the on-prem one, but we have Terraform Cloud and Terraform like the open source one, so this is wrong. Is used to configure applications on Google Cloud. Not configure, as we remember, like there was a whole topic of provisioning versus configuring. It is for provision. Terraform can be used for multi-cloud deployments. Yes, parallelism and like all those init, we can have multiple inits. Terraform uses the imperative approach to define infrastructure components. Was it declarative or imperative? I think it was imperative, right? I will say imperative. This one. It is used for multi-cloud. I think at one point you can have one cloud, right? In one init file. Maybe I might be wrong. Feel free to let me know. LO. Define. What is LO? What the hell is this? Meaning. Okay, LO means like draw attention here. Oh, what is going crazy? Define infrastructure as code. What is infrastructure as code? Infrastructure as a code is a process to define, provision, and manage cloud infrastructure by writing codes in file. Yes, infrastructure as a code is a data warehouse running on serverless infrastructure. That does not define. This is what happens behind the scene, but this is not what defining infrastructure as a code. IAC is a cloud computing model that offers resources on demand to business and individuals by using cloud. No, that does not define it. It's how it is offered. IAC is a tool to maintain consistency in application deployment environment. No, I will say still does not define like the infrastructure part of it. This is the best one. Explain the use cases of Terraform for Google Cloud. Select the two use cases for Terraform. Two use cases of Terraform: automate changes. Yes, kind of. Run operating system level customization. No, it does not. That's configuring. It's not provisioning. Terraform is for provisioning. Provision and application. Provide financial analytics, standardized configuration. We know automate changes is one. Provision and application. Provision infrastructure. Infrastructure. Huh. This one is confusing. This one is good, I guess. Provisioning infrastructure using provision standardized configuration. It standardizes the infrastructure. I'll go with provision. Explain use case of Terraform for Google Cloud. Select the 3 Terraform editions available in production. Use cases of Terraform for Google Cloud. Use cases. 3 Terraform editions available in production. Terraform Cloud is there, Enterprise there, there's open source. There's nothing as cyber, nothing as analytics. So let's see how right and wrong we were. Explain the feature. I got 50. Okay, so 2 were right. I use, wait, it's multi-cloud, okay. I'm bad with English, man. Automate changes, so this one will be standardized configuration easily. Let's do again. Feature benefits, which one of the following statement is true? Multi-cloud then, right? Then imperative is not the right one, so standardized configuration, automate changes, consistency computing, yeah, and then here cloud, enterprise, and open source. So I think we should be good in this one. Yep, 100%. I wish there was explanation here, but that's fine. Okay.
This brings you to the end of the first module and the getting started.
I know this is like I have been not doing streaming on YouTube, so I understand it takes time to build the community. So just like in Twitch, it took me like a year to build it. Got banned, so for no reason properly. So it will take me a year to build that community again, but that's fine.
This brings you to the end of the first module in the Getting Started with Terraform for Google Cloud course. This module covered the basics of Terraform and infrastructure as code. We defined infrastructure as code and covered the business case for IAC. We explained the features and benefits of using Terraform. We also discussed the common use cases, how to use Terraform, and the consumption model for Terraform.
Great. So that ends our stream for the day. Thank you so much for whoever was watching. I saw like 5 people watch today, so it's great. Thank you for supporting. It's nice to see at least 5, like in what's this called, during Twitch. It took me like months to reach 5 months, and so it's like with the YouTube, it's nice. So thank you so much and have a great day. I'll see you guys soon, probably tomorrow with another stream like this. And yeah, till then, keep coding, be happy, and enjoy cloud.